Matrix multiplication using Python. We know the rules of matrix multiplication. That is, the number of column of the first matrix should be equal to the number of rows of the second matrix. Now let us consider two 2 by 2 matrices. Now according to the rule, the number of columns of the first matrix should be equal to the number of rows of the second matrix. Let us consider the indices of A, Ij and B, Kh. Now the dot product of these two matrices will be AE plus BG, AF plus BH and CE plus DG and CF plus DH. Let us consider RC as a indices of the resultant matrix. For making an algorithm, we have to first understand the properties of the multiplication. For that, let's look into the indices of each element in the product. Now, if we look carefully, we can see that the indices of J and K always same for all the products. Now, if we look into the indices of the resultant matrix, for the first element we can see that I vary only one time, H vary one time, for that J and K vary two times. For the second element of the resultant matrix, it is same, I doesn't vary, but for that H vary one time and J and K vary two times. Now, if you look into the entire row of the resultant matrix, that is the first row of the resultant matrix, we can see I vary one time, for that H vary two times, and for that J and K vary four times. Now, this is true for the second row of the resultant matrix. I vary one time, H vary two times, J and K vary four times. Now, if you look into the entire matrix, we can see that I vary only two times, for that H vary four times, and J and K vary 8 times. Now, we can use these properties for the development of the multiplication algorithm. Matrix multiplication algorithm. Okay. For simplicity, we will take only 2 by 2 matrices. Let us consider X is the first matrix. So 1 and 2, then 3 and 4. Similarly, for Y matrix, it will be your, suppose it is 5 and 6, and then 7 and 8. You can take any dimension, but it will be easy for your understanding if you take the 2 by 2 matrix. Okay. Now we will convert it to a array. For that, we have to first import the NumPy library. Import NumPy S and P. Okay. Now we will convert the X and Y into an array. np.array of X, Y equal to np.array of Y. Okay. For the multiplication purpose, we have to store the dimension of the matrices. For the first matrix, we will store it in capital I and J. It will be X dot shape, SSAP. Okay, so it will store the dimension of the first matrix. Similarly, for the second matrix, it will be K and H equal to Y dot shape. Okay, so it will give the dimension of the Y matrix in K and H. Now we need to store the resultant matrix. If you go by theory, the dimension of the resultant matrix equal to the number of rows of the first matrix and column equal to the number of columns of the second matrix. So we have to declare accordingly. Suppose we will store in Z. So Z equal to, we will initiate it with the zeros matrix. So np.zeros having dimension equivalent to the number of rows of the first matrix and number of coulombs of the second matrix, which is coulomb by H. So it will provide you the zeros matrix of being the dimension of the resultant matrix. Now we are going to implement the multiplication algorithm. As we discussed in the earlier section, the least variation happened in the ith indices, then in H, then in J and K. So we are going to implement accordingly. So for that, we declare a for loop for I in range of capital I, and then for J in range of capital J, capital H, and then for K in range of capital K or capital J, anything. So we will store the product in Z of I and J equal to plus equal to X of I comma K into Y of K comma J, and then print Z. So that's it. Very simple.